Now we are going to plot the values on a graph sheet. Our step 1 is location of poles and zeros. So from the problem, we are having 3 poles, right? One at 0, one at -2 and another one at -4. So here we are locating those values 0, -2 and -4. Right, this is our step number 1. And second one is to find the existence of root locus on the real axis. So this is our negative real axis. Now we are going to select a test point. Right, let our test point be at -2. If you look at the right hand side of this test point, you see how many number of poles are there? We are having only one pole, so it is an odd number. Therefore, the root locus exists between this 0 to -2. Right. When you take it another test point at 2.5, okay, -2.5. When you look at the right hand side of this test point, we are having 2 poles, right? So it is an even number. So root locus does not exist between this -2.5 and 2. Similarly, here now we are selecting our test point as -4, right? So how many number of poles are there on the right hand side of this test point? So to this test point right hand side we are having 2 poles. So it is an even number. So again root locus does not exist between this -2 and -4. Again select test point somewhere after -4, that is -5 or -6. Right. So now let us consider our test point as -5. So to the right hand side of this test point, so this is our right hand side, right? So how many poles are there? We are having 3 poles. So it is an odd number. Therefore, root locus exists at these points, right? Even when you consider -4.1. Okay, consider this point. Let it be -4.1. When you look at the right hand side of this point, again we are having 3 poles. So it is an odd number. So root locus exists between this 4 and 4.1. Likewise, whatever may be the test point you take, even if you take the test point as -100, to the right hand side of that -100, again we will be having the same 3 poles. So therefore, root locus starts at 0 and ends at -2, and again it starts at -4 and it extends up to infinity, right? So this is our step number 2. Then the step number 3 is centroid. So what is the value of centroid? It is equal to -2 here. So just mark the point. So the value of centroid is -2. So here I had marked that point, right? Then now we are going to mark the angle of asymptotes. The value of angle of asymptotes are, you see, here the first angle is ±60 degrees. So these are the different angle of asymptotes. Now we are going to mark these angles, right? We have to keep the protractor at centroid and we have to mark these angles. So here the first angle is ±60 degrees. So we have to mark +60 degrees. So here, from here, just you move gradually and you just keep a point for +60 degree, right? And the second angle is ±180 degrees. So it is a straight line, no need to mark. And our third angle is +60 degree. That is, we have to mark -60 degrees. So if we have negative angle, just you have to reverse the protractor and you have to mark it. So just reverse it and just mark your 60 degrees here, right? Then our next angle is ±60 degree. You see the angle gets repeated, so no need to mark. That's it. Now we have to join this centroid with this angle of asymptotes using dotted lines. So here we have joined our centroid with the angle of asymptotes. I had joined those 2 points using a dotted line, right? So then our next step is we are having a breakaway point. The value of this breakaway point is -0.845. So here lies our -0.845, right? Just keep a mark on it. Then the next thing is we are having a crossing point of imaginary axis. So the point is plus or minus 2.8j here. So here lies our plus 2.8j and here lies our minus 2.8j. So just keep a point on that respective points. Right. Now we are going to draw the root locus. So this is our breakaway point. Right. So the root locus, we had already seen that root locus exists between these two poles, right? So here we are having root locus. This root locus breaks away, okay? It gets distracted, it gets breaked at this point. So the thing is, it is an assumption that, not an assumption, it is a fact that the root locus always starts at pole and ends at 0, right? We had seen previously. So here, one branch of root locus, it starts at this pole, it moves over here, it gets break over here, and it crosses the imaginary axis at this point plus 2.8j, right? So here you can just mention it using a arrow marks. Then the next thing is, this is a breakaway, right? So here we are having a root locus. Again the same thing. This branch starts at this pole. It comes to this point and it gets breakaway, right? So after getting breakaway, it travels and again it crosses our negative imaginary axis at this point. So again you have to mark the arrowheads like this, right? So finally, we had drawn the root locus. So this root locus has how many poles? We are having 3 poles, right? So this root locus should has 3 branches. So how to mark the 3 branches? You see, here one branch starts at this pole. It travels and reaches this point and gets breakaway. It crosses the imaginary axis at plus 2.8j. Right. And another branch starts at this pole. It gets breakaway at this point. And again, so it starts from this pole, it travels and again it gets breakaway and it crosses our negative imaginary axis at this point minus 2.8g. Right. Then our third branch of root locus starts at minus 4 and it extends up to infinity. Right. The thing is, we have to find the value of k if the value of zeta is 0.5, right? If the value of zeta is 0.5, the cos inverse of 0.5 is 60 degrees. So, the value of k corresponding to the point at s equal to sd, here sd is said to be a dominant pole, right? So, k is nothing but product of length of the vector from all poles to the point divided by product of length of the vectors from all zeros to the point. Now, here we are asked to find the value of k, right? Given that the value of zeta is 0.5, when you take cos inverse of zeta, it gives rise to 60 degrees. So, here you have to keep the protractor at this point, that is pole at origin, right? Then you have to mark that 60 degrees. After marking that point, just you have to draw a line from this origin to this point. Right. So after drawing this line, you see our line intersects the root locus at a particular point and this point is said to be dominant pole. Right. So to this point, now we are asked to calculate the length, right? So that we can find the value of k. So now we have to find the length of this point from these poles. Here we are having 3 poles, right? So from this pole and this pole, we have to calculate the length. This is done by using a scale. So just by using scale, I had measured the values of L1, L2 and L3. So these are the respective values in centimeters, right? But these values should be adjusted according to the scale taken. Here you see 1 centimeter is equal to 0.5 units. So the thing is, you have to multiply each centimeter with 0.5 so that we will be getting a uniform scale. So when you multiply 6.8 into 0.5, what happens? It gives the answer of That is into 0.5 is nothing but divided by 2, right? We can write it as 1 by 2. So you just divide everything by 2. So what will be the answer? Here it will be 3.4 and here it is 1.3, right? And here it is 1.75, right? So these are the values of your L1, L2 and L3. Just now we can substitute these values in the formula. So here just substitute the values of L1, L2 and L3 and divided by, you see, product of length of vectors from all zeros. In this problem we don't have any zeros, so the denominator term we have to keep this as 1 here, right? So here in our calculation we had find out the value as 3.4. There may be some difference, right? It may be 3.4 or 3.5. It won't make much bigger difference. So just from the measurement you just write down the values, and here finally the value of k is found to be 8, right? So here comes the ends of the problem. If you have any doubt, let me know in the comment section. Thank you.